Let's do another video on limits. A lot of this should be reviewed, but some of it may clear up some questions you had from the other two videos we had. So as you remember, we're talking about limits. And when we talk about limits, sometimes we talk about a speed limit, a spinning limit, or a cutoff, like how many people are allowed in the building to a fire code. When we're talking about limits, we think of some sort of maximum or some sort of minimum boundary. In math, the idea is a bit more involved, but it doesn't really have to do with minimum or maximum boundary. It's actually a limit is a numerical value, and it's a value that a function approaches. So it's going to be f of x, get a little curve, and then we're going to pick a number, and we're going to see what number we approach coming from the left or the right side of some random x value. All right, so first let's look at some everyday scenarios to kind of get the idea. So in the first one we have you're walking up a ramp to enter a building. As you walk up the ramp, how high above the ground are you getting close to as you approach the end of the ramp? So as you're walking up the ramp, you are getting closer and closer to 3 feet. All right, so that's scenario number one. If we look at scenario number two, ants are climbing up this limb. And you really don't like ants. So every time they get to close to the top, you flick them off. So they're never ever going to get up to you. They're going to get close. But as they go up the limb, as they get closer and closer to the end of the limb, they're reaching 6 feet. A third scenario is you're at the pyramids, and one person is walking up one side of the pyramid, and another person is walking up the other side of the pyramid. And as you both walk towards the top, the question is, are you walking towards the same vertical height, And that answer would be yes, because you're both going to the same height above the ground. A fourth scenario is escalator. So you're at the mall and there's a grand chandelier in the middle of the mall, and one elevator goes up this way, headed towards the chandelier. The other one goes up this way. And in this one, the question is, are you approaching the same vertical height? Is the guy approaching on the same height as the girl is? And the answer is no, because the girl is only going to get this high at the end of the escalator, while the guy is going to get a little bit higher. So they're approaching different heights, one coming from the left, one coming from the right. Okay, so now let's look at these scenarios in terms of math. So scenario number one, the ramp. On the ramp, you're walking on the graph. Let's imagine you're walking on the graph, and you're on the left side of 2. So we're on the left side of 2. And as you're walking closer and closer to 2 on the x value, what's going to be the y value you're approaching? Well, that y value you're approaching is going to be 4. So coming from the left, you're going to head towards 4. The second one, we're talking about the limb, the ants on the limb. And so the ants on the limb are walking towards a -4 this time, let's say, walking towards a -4. So they're headed this way. And as they get closer and closer to a -4, sorry about that. As they get closer and closer to -4, they're heading towards the value of 1 on the y value. Now, they're never going to get there because, remember, an open circle means not equal to, where if it was a closed circle, that would mean it's equal to. So they're getting closer and closer to 1, but they're never going to get to 1 because that value doesn't exist on a graph. In our third situation, we have the pyramid. and two people walk on the graph. One is on the left side of 0, and the other one is on the right side of 0. And so this person is going towards 0. This person is going towards 0. Now, the first question is, are you getting closer and closer to the same value? So they're headed towards this right here. And when they get to 0, both are going to be there, whether they came from the left or the right. So are they getting closer to the same value? That answer is yes. That value is a -1. And our last scenario would be the chandelier, the escalator. All right, so the guy is headed towards the chandelier, and we're going to put the chandelier at 1. So the guy's headed towards the chandelier, the girl's headed towards the chandelier, but are they getting closer to the same y value? No, they're not. The dude, he's getting closer and closer and closer. When he gets there, he's going to be at a value of 1. And the girl, she's getting closer and closer to a value of 3. So coming from different sides of x equals 0, we're coming closer and closer to a different value. So when it comes to limits, as you get closer and closer to an x value, the limit is the value of the y that the function approaches. In some of the scenarios, one person walking on the function in a particular direction, and others, two people walking in different directions. It's important to understand not only what it means, but how it's expressed mathematically. Let's use scenario number 4, the escalator. So graph the function. So approaching from the left. And so when we're approaching from the left, that little negative sign, that means we are approaching from the left. So if we see a negative sign on the right side of the number, that means we're approaching from the left. And as we approach from the left, we are getting closer and closer to a value of 1. So the limit as x approaches 1 from the left side of the function x would be 1. If it's coming from the right side, then we're going to have a plus sign over here. And if we look at the girl coming from the right side, as she gets closer and closer to an x value of 1, her y value is equal to 3. So her limit is going to be a 3. So notice that the limit of function does not have to equal the value of the function. Because if you look at the girl, there is no value at 1. So when she gets there, there's no value. But she's getting closer to 3, even though there's no value for the function coming from the right side at 3. Okay, consider for a moment the x value of functions being approached. We can have a limit on the left side. We have a limit on the right side. But if we're talking about the limit, the limit is going to be the value when it's the same number, when it's the same value, when it comes from the left side and from the right side. So if they have the same value coming from the left side and the right side, then it has the limit. And so math scenario number 3 with the pyramid. Remember on the pyramid, they both walked up on the left side, one on the left side, one on the right side, but they were both going to the same value. Right? So here's number 3. The guy's going towards -1. The girl's going towards -1. So we could say that as the limit approaches 0, it has a limit, and that limit is -1 because same from left and right. All right, so if it has the same value, it has a limit, the limit. If I look at scenario number 4, one person is going headed towards this value. On the other side, coming from the right, has that value. So coming from the left and the right on that situation, there is not one number that both of them approach. So then we would say that limit does not exist, and we could abbreviate with D N E. Okay, so that's limits. What I want you to do now is I want you to work with a partner, answer A, B, C, D, and E, and then I'll go back to Google Classroom, and I'll have a short little video that has the answers and explain the answers to make sure you're getting those right. There is no homework tonight. You're welcome. Just go home and think about limits. Next class, we will have some more to do with limits, and there will be a little bit of homework, but not that tough. If you have any questions, as always, Google chat me.